Alright, so today we're going to concentrate on that last rule that we saw yesterday, and that's looking at exponential equations. How do you solve an exponential equation? If you look at the top of your notes there, they give us two examples. First thing I want to point out on the first example is that the bases on each side are alike, meaning that this is a 3, this is a 3. This is the base that they're referring to. Notice how they're exactly the same. And what we found out yesterday is if those bases are the same, then we can take the two exponents and set them equal to each other, which is exactly what they did here. They took the two exponents, set them equal to each other, and from there it's just a matter of solving the equation, which in this particular case, if we solve that equation, we end up with a 4. However, we can only do this if the bases are the same. Look at the second case, the second example here. Notice how the bases are not the same. Here I have a 3. Here I have a 1/9. Anytime the bases are different, you're going to have a little extra work. It says here you're going to have to rewrite each side so that you do have a common base. And that's what they did here. They took that 1/9 and rewrote it as 3 to the negative 2 power. Because 3 to the negative 2 power is the same thing as a 1/9. And we'll talk more about that in a second. And now that it has a common base, now it's just like the first example. We can take the two exponents, set them equal to each other, and solve. So this is what you guys are going to be seeing today. Those are just two quick examples that they gave us. We're going to work several examples of our own. All right, so let's get started. We're going to start off with a couple of easy ones. Look at number 1. My first question is number 1, do they have the same base? Yes. Notice how we have a 5 for the base here and a 5 for the base here. And because that's the case, all we have to do is take the two exponents and set them equal to each other. Which means I'm going to do x minus 7 equals to 2. Those are the two exponents. I'm just setting them equal to each other. At this point, it's just the equation, just like you've seen back in Algebra 1 in geometry. We're going to solve for x. Anybody know what I need to do to solve for x? Add 7. We're going to add 7 to both sides. And when I do that, 2 plus 7 should give us a 9. Therefore, the solution to this equation is x equals a 9. Now, just like you do with any other equation, you can always check your answer to make sure it's correct by taking that answer and substituting it back in. So if I take this 9 and substitute it in for that x, what do you get when you subtract 9 minus 7? 2. Is a 5 squared going to equal to a 5 squared? Yes. So we know we have the same answer, the correct equation, or right answer. We're going to skip 2 and 3. I'll come back to it in a minute. I want to do one more easy one before I get to something a little more difficult. Let's take a look at number 4. I want to point out number 4 has the same basis. Notice how there's a 2 and a 2. And because those bases are the same, all we have to do is take the two exponents and set them equal to each other. So that's what I'm doing right here. Just taking the two exponents, setting them equal to each other. At this point, all I got to do is solve for x. You guys have been doing this for several years now. How do I solve for x? What can I do first? Caleb, what can I do first? Okay. What can I do first? Garrett, what can I do first? Move one of the x's over. All right, sounds good. I'm going to move this 2x to this side over here by subtraction. So 1x minus 2x would be a negative x. So at this point, I've got a new equation, and that's negative 1 for negative 1x plus 1 is equal to a 3. What's next? Samantha, what can I do next? Subtract what? 1. Very good. We're going to subtract 1 from both sides. So what do you get when you subtract 3 minus 1, Samantha? 2. Now, this is not the answer yet. Alexander, I got one more thing to do. What are we going to do here? By what? Divide by negative 1. That's to get rid of that negative sign. And 2 divided by negative 1 is negative 2. Therefore, our solution to this equation is negative 2. And again, I could do the same thing I did with number 1. Take that negative 2, substitute it in for the x, and the left side of the equation should equal to the right side of the equation. So these first two that we looked at, pretty easy because the bases were already the same. But what if they're not the same? Well, let's go back over here to number 2. Notice number 2, the bases are not the same. Here I have a 2, here I have an 8. And because of that, I cannot set the exponents equal to each other. So somehow, some way, I got to figure out a way to get these bases to match up. So here's what we're going to do. I'm going to leave the right side, or not the right side, but the left side of the equation the same. I'm not going to worry about the left side. It's the right side that I need to work with. That 8. Somehow, I need to rewrite the 8 so that it has a base of 2. I want them to match up here. So let's think about this. 2, so what power would be the same thing as a 8? 3. 2 to the third power is the same thing as a 8. So that's the exponent I'm going to use. All right, so let me get rid of my question mark here. We all agree that 2 to the third power is 8. Notice now it's just like number 1. Now we got the same basis. All we have to do now is take the 2 exponents, set them equal to each other, and solve it. All right, so what are we going to do first, Mason?
Add 4.
Add 4. And what do you get, Mason, when you have 3 plus 4? 7. All right, Matthew, what are we going to do next? Divide by 3. And what do you get when you divide by 3? Now, we got a choice here. We can do a decimal or we can do a fraction. I prefer the fraction. What would the fraction be for 7 over 3? Can I reduce 7 over 3?
No.
No. So we would leave it as 7/3. So the solution to number 2 here is 7/3. So I had to do one little extra step, and that was to rewrite the 8 as a 2 to the third power. Because remember, you do have to have the same basis before you can have or set the exponents equal to each other. All right, so let's try the same thing on number 3. We're going to see if we can figure out a way to get the not the exponents, but the basis to be the same. Right now, here I have a base of 16. Here I have a base of 4. So somehow, I want those two bases to match up. So think about it. What can we do so that the bases are the same? Virginia, you got any ideas here? What can we do? Is there any way I can rewrite a 16 so that it would have a base of a 4? Four. Four what? Squared. 4 squared is the same thing as a 16, isn't it? Okay, so that's what I'm going to do. I'm going to rewrite this 16 as a 4 squared. They're equivalent. They mean the same thing. So that 16 has now become a 4 squared. However, I do still have that exponent of 2 minus x. So let me go ahead and rewrite that. Of course, I didn't touch this side. It's still the same thing. So notice how the bases are the same. We have a base of 4. However, if you look closely here, now on the left side of the equation, I've got 2 exponents. And yesterday we saw a rule that says you do what when you have these 2 exponents? Do I add them, subtract them, multiply them? What did that rule say yesterday? Nope. Multiply. So what do you get when you take these 2 exponents and multiply them together? 4 minus 2x. It's distributive power. So we're going to end up with 4 minus 2x. 2 times 2 is 4. 2 times that negative x is negative 2x. The other exponent is going to stay the same. 2x plus x. All right, so there's the equation that we're working with. That's what we need to solve. So let's go ahead and solve it. I think what I'll do is subtract this 4 first. So that's negative 2x equals 2x plus 4. Now I'll go ahead and move the 2x over here to the left. negative 2x minus 2x is a negative 4x. Then I'll go ahead and divide by the negative 4. And a 4 divided by a negative 4 turns out to be a negative 1. So the solution to number 3 is negative 1. So again, the tricky part here is figuring out how to rewrite the 16th. Once we have it rewritten, then it's just a matter of taking the two exponents, setting them equal to each other, and solving. But it is a little tricky, especially some of the bases that we're going to come across. All right, let's go ahead and go to number 5. Again, we're going to run into the same problem. Notice how the bases are not the same. So we got to figure out a way so that we can get this 81 and this 27 to have the same base. So how can I rewrite an 81? How can I rewrite a 27 so that we end up having the same base? What's that? 9 equals 9. Okay, but remember, we're needing exponents.
9 squared.
Okay, let's try this. So you're saying that 9 squared is the same thing as a 81, and that is true. I like it so far. Sounds good. But that's not the base that I have on the other side. I have a 27. So what are you suggesting I do with the 27? Make it a... No, I like those. Say what you're going to say. What are you talking about when you say 3? You said the 3. I want to know what were you
Wouldn't it be 3 to the third? 3 to the third side?
For what? For the 27? You are correct. When you say 3 to the third power is 27. But then the bases still don't match up, because on one side I got a 9, on the other side I got a 3. So what you told me here is correct, but that doesn't help me. Okay. So you're saying instead of using 9 squared, that we should use a 3 to the 4th. I like it. That sounds better.
How do you know if you look at
Well, remember, when I get through with this, the bottom line is that the two bases have to be the same. If I have a 3 for my base on the left, I have to have a 3 for my base on the right. They got to be exactly the same number. So 3 to the 4th power is the same thing as a 81. 3 to the 3rd power is the same thing as a 27. Of course, over here on the right side of the equation, I already had an exponent of x minus 1, so I can't just throw it away. So here's what I'm working with. Now that the bases are the same, I'm going to go ahead and set the two exponents equal to each other. But before I do that, over here on the right side, I do have two exponents. So as we did earlier, we're going to take those two exponents and multiply them together. So what do you get when you multiply the 3 with the x minus 1? 3x minus 3. That's what you get when you multiply those two exponents together. All right, now let's go ahead and solve for x. I'm going to add 3 first. That's 7. Now I'm going to divide by 3. And like we saw earlier, instead of giving me the decimal, I'm going to use the fraction 7/3. Therefore, the solution to number 5 is 7/3, 7 over 3. So again, it's a little tricky in finding how to rewrite those bases. This comes with practice. All right, now let's go to number 6. Same situation. Over here on number 6, the base is a 1 over 25, and the base over here is a 5. So somehow I got to get these two to match up. So let's see if we can figure this out. I'm going to get you started here. I will tell you that the right side of the equation is going to remain the same. Give you that one. I'll also tell you if we're going to keep that right side the same, then the base I'm looking for is a 5. So I'm looking for 5 to the something power that would equal the same thing as a 1 over 25. So think about it. 5 to what power would equal the same thing as a 1 over 25? What's that? Very good. Negative 2. So the exponent that I'm looking for here is a negative 2. Why negative 2? Well, first of all, 5 squared. Wouldn't 5 squared give you the 25 part? Yeah. Yesterday, didn't we say that negative sign means what? Reciprocal. And that's what's giving us the reciprocal, that 1 over 25. So this is why we're using a negative 2. 2 because of the 25, the negative sign because of the reciprocal. All right, now that we have the same basis, all we got to do now is take the two exponents, set them equal to each other, and solve. That's an easy one. Let's come over here and add. All right. And what's the negative 2 plus 5? 3. Therefore, our solution here is 3. So again, it's really not that difficult. The trickiest part is making sure that we have the same basis. And this is the part that probably is going to give you the most trouble. However, there is some good news. If you get stuck, can we use the calculators to help us out? Yes. Yes, you can. Let me show you how that's going to work. Let's take a look at this first example here. We got 3 to the 2x minus 4 power is equal to 3 squared. Now, I'm going to go ahead and do it the same way that I did the others. Notice how the bases are the same. They're both 3, which means that I can take the two exponents, set them equal to each other, and solve. There's the two exponents equal to each other. What do I need to do first if I want to solve for the x? Add 4, right? And what do you get when you add 2 plus 4? 6. So now I have 2x equals 6. Okay, so the first thing we did was add 4. Then what would you do? Divide by 2. And what is 6 divided by 2? 3. Therefore, the solution to this equation is x equals 3. So the question is, how is it that we can use our calculator to come up with that same answer? Let me show you how that works. Go to your calculators and go to y equals 4. Go to y equals. And in y equals, what I want you to do is in y1, you're going to type in the left side of the equation. You're going to type in that 3 to the 2x minus 4 power. Then what you're going to do is in y2, you'll type in the right side of the equation, the 3 squared. All right, once you got them both in there, we can find the answers in 2 different places. I want you to look at your table first. Everybody go to your table, second graph. And the table you see on your calculator is the same thing that I have up here on the board, guys. Now, we already worked it out, and we already know that the answer is 3. X equals 3. What 2 numbers do you see sitting next to that 3? A double 9. Each of the y values is a 9. So, when we're looking for our solution in the table, all you got to do is look for the matching y values. And if you can find the matching y values, sitting right next to those matching y values is your solution. Okay? So if I see a 9, 9, well then I know my solution is sitting right next to that 9, 9. Not only can you find it in your table, but you can also find it in your graph. So now look at your graph for me. Everybody look at your graph. Where are we going to find this 3 in our graph? Well, where they intersect. That is correct. Anybody remember how to use your calculator to find your point of intersection? How do you do that? Second trace. Number 5, intersection. Just remember you're going to have to hit enter 3 times. Enter, enter, enter. It'll find that point of intersection. And down at the bottom of the screen, what's the x value you see down at the bottom of the screen? 3. Okay. So, we've got 3 different ways that we can find the solution to this exponential equation. We can do it algebraically, which is what we did first. We can look in our table for the solution. Or we can also look in the graph for our solution. So you got 3 different ways to find your answers here, guys. Let's try that again. Let's try it with another one. Now, to save some time here, let's go ahead and do this one with our calculator. Here's the nice thing about this. You don't even have to rewrite the 8, guys. You can type it in your calculator just like you see it. Okay, so let's go to y equals. And in y1, let's type in the left side. And in y2, we'll type in the right side. Again, this is the nice part about using your calculator. You don't have to rewrite anything. Once you got it in your calculator, let's not forget what we're looking for. We're looking in our table for the matching y values. So see if you can find the matching y values. If you can find those matching y values, well then you found your solution. Okay? Anybody find the matching y values? Well, what are they?
-1.
8 and 8 were the matching y values, and what was sitting next to that 8 and 8? -1. So guess what the solution is? The solution is -1. Let's go ahead and take a look at the graph real quick. If we look at the graph on your calculator, your graph looks something like this. You've got an exponential. You've also got a horizontal line. If we find that point of intersection is also going to be a -1. Yeah, go ahead and draw it for me. So again, I'm showing you 3 different ways to come up with your solution. So if you get stuck algebraically, is there a backup plan? Yes, you can use your calculator. All right, any questions so far? We're good.
Is this like one of those things that it only works some time?
This is going to work pretty much most of the time. Now there are occasions where we might have to tweak it a little, but for the most part you should be okay, especially with the assignment that you're going to have today. All right, let's go ahead and take a look at the next part here. Now this real quick, the directions say solve these equations using your graphing calculator, show your table and your graph. So let's do a couple of those real quick. Let's start with number 7. Again, right now all we're doing is using our calculator. We'll go back to the algebraic way here in a second. So, in y1, we're going to put in this. In y2, we'll put in this. So go ahead and go to your calculator. Once you get it in your calculator, you're going to go to your table. And just like we did a second ago, we're going to look for the matching y values. That's what we're looking for. You can find the matching y values. You can find your solution. Matching y values. Anybody find the matching y values? What were the matching y values? 0.5 and 0.5. These were the matching y values. And what was sitting next to those 0.5s? -2. So what does that mean for us? It means that the solution of this equation is -2. So that's one way to find the answer. Or we can also look at the graph. Now notice on this graph you have 2 exponentials. You got one curve that looks like this and another curve that looks like this. This time it's 2 different curves, and that's because we got 2 exponentials. We got an exponential on the left side of the equation. We also got an exponential on the right side. But it is going to work the same way. You're still going to go to second trace. You're still going to find the point of intersection. And that point of intersection is still going to be that x equals to a -2. So even though you don't get a horizontal line, you're still going to treat it the same. You're still going to find the point of intersection for it. All right, so again, number 7, the solution here is -2. And all we did was put it in our calculator. Let's do one more here. Let's do number 8. Number 8. Again, go ahead and use your calculator for me. This is going into y1. That's going into y2. Once you got it into y1 and y2, we're going to go to the table, and we're going to see if we can find the matching y values. Matching y values. Anybody find the matching y value? Everybody in your table? Anybody find the matching y value? Uh-oh. Sure, Caleb, you didn't find the matching y value? Alexander, you didn't find the matching y? All right, the reason you're not finding a matching y value, guys, is because our answer is going to end up being a decimal or a fraction. So, how are we going to find it if we can't find it in the table? Where else can we find it? In the graph. Go to your graph now. Since we can't find it in the table, go to your graph. Find the point of intersection. Second trace. Number 5. By the way, your graph should look something like this here. You're going to get an exponential. You're also going to get a horizontal line. I'm asking you to find the point of intersection. As I mentioned, it is going to be a decimal. The question is, what is that decimal? 2.333333, so on and so on. Okay? So the reason you couldn't find it in your table is because it ends up being a decimal. So if we were looking for it over here, we would be looking for 2.33333. Anybody know what we would see next to that 2.333? Guess what you would end up saying? What would be the two y values? What do we know about these two y values? They got to be the same numbers, right? 8 and 8. So go ahead and write that down for me. That's what it would look like on the table. Of course, we wouldn't see that because we don't have our table set up to count by thirds. By the way, that 2.333 can also be written as a fraction, and that fraction is 7 thirds. Wait a minute, this sounds familiar. 2 to the 3x minus 4 power equals 8. Haven't we seen that before? Turn to the first page again, guys. Turn to the first page. Isn't that the same as number 2? And number 2, didn't we get 7 thirds? So we've actually worked this out algebraically already. Same thing for number 7 over there. Number 7 is the same thing as number 4. About number 9. Didn't we work that one already? What did we get earlier for number 9? That was the same thing as number 6, and the answer we got for number 6 was what? 3. So again, we're just showing you that there are options. We can work things algebraically. We can do it with the table, or we can also find a solution.
At this time, the new report cards are in boxes so that you can pick them up. Please try and get them so that they can be distributed this period. Thank you.
All right, last thing we have here. Is some inequalities, and this is going to work pretty much the same way. There's not a whole lot different here. So just real quick so you can see it. First example, notice how the bases are exactly the same thing. We've got a 3 and a 3. So I want to show you how we can do this algebraically. Because the bases are the same, we can take the two exponents, 2x minus 4. Now, a second ago, we were working with the equation. So all we did with the equation, we set the two exponents equal to each other. But we're not working with equations anymore. Now we're working with inequalities, which means instead of using an equal sign, instead of that equal sign, now I'm going to be using the inequality symbol, which in this case is going to be the less than. Less than.
It's always the same.
Yeah, it's always going to be the same as what we have. So now it's just a matter of solving for x. So over here, if I add 4, 2 plus 4 is 6. Divide by 2. 6 divided by 2 is 3. Therefore, x is less than a 3. So, like I said, not a whole lot different other than just using a less than symbol rather than the equal sign. Now, notice here we can also use this or find the answer in our table. It's a little trickier in what we're looking for here. But let's go ahead and try it. Everybody go to your calculators and go to y equals 1. And just like we did earlier, In y1, we'll type in the left side. In y2, we'll type in the right side. I want to make sure you understand what we're looking for in the table distance. When you get to your table should look just like mine. Now, just like we saw with the equations, if you look next to that 3 there, you'll notice next to that 3 we have matching y values. But remember, we're working with an inequality, not an equation. So notice over here, these first y values, y1, represent the left side of the inequality. The y2, or that last column over there, represents the right side of the inequality. And what we have here is we're saying we're looking for what x values result in y1 being less than y2. Well, all of these right here, all of these would end up with y values in y1 being smaller than the y values in y2. In other words, this number, this number, this number is less than these numbers over here. That's what this is saying right here. So it's just a little bit trickier looking at it in the table and the graph. Of course, we can also see the same thing in the graph. Here's that point of intersection 3. And because we're looking for those y values, or y1 values being less than y2, it would be to the left. By the way, that is an open circle because of the fact that we don't have the equals. All right, so I'm going to work one more with you. We're going to skip that last one because we're running out of time here. So let's look at number 10. And I'm going to go ahead and stick to just algebraic here real quick. That 8, remember, we're going to rewrite 8 as 2 to the 3rd power. Because in order to solve this algebraically, I do need to have matching bases. Now that we have matching bases, we can go ahead and take the two exponents, which are 3x minus 4. We're not going to set them equal to each other. This time it's going to be less than or equal to a 3. So again, the only difference is instead of using an equal sign, we're going to use the inequality. From here, it's just a matter of solving for x. So I'll add 4. 3 plus 4 is 7. Divide by 3. And we end up with x is less than or equal to a 7/3. And there we have both equations and inequalities. All right, that takes care of the notes.